Okay, here is part 2 of Integrated 1 Lecture 11.2.1. I was going to do this mixture problem. It's number 10. It says how much coffee costing $6 a pound should be mixed with 3 pounds of coffee costing $4 a pound to create a mixture costing $4.75 per pound. So I don't know how you would go about doing this if you're just trying to, you might be able to common sense your way through it. But it turns out we can just kind of use our formula. Well, I'm not going to show it on here. Our formula is, we know that, where can I write this? Down here. We know that distance equals rate times time. And we also know that cost is, like the total cost is like if this is the total cost, then it's how much each thing you buy is let's say this is total price, and then how much each thing costs times however many things you buy. Right? You can kind of tweak this formula and make it do different things. So the way that we're going to try to do this problem is we're going to say however much this first type of coffee, because remember we're mixing two different kinds of coffee. So the first type of coffee, that's $6 a pound, times, because however much we're going to have to pay is going to be $6 times however many pounds of that there is. It doesn't say how many pounds there are, so I'm going to put an X for that. And then we're going to add that to 3 pounds of coffee that it's $4 a pound. Well, it's $4 a pound. Okay, so I'm going to put 3 in my pounds spot, and it's $4 a pound. So I hope that makes sense. This is one type of coffee. It's the more expensive type of coffee. And then this is the less expensive type of coffee. I actually teach this out of a Saxon book sometimes, and they say this is your poured in stuff and this is your dumped in stuff, because that's how they do mixture problems. It's kind of like we poured in this expensive coffee and then we dumped in some of this cheap coffee, and then we're going to mix it all up, and we want to get a coffee that averages out. After we mix it all together, we want it to be $4.75 a pound. And how many pounds are there going to be? Well, there's going to be however many pounds I dumped in of the $6 coffee, plus the 3 pounds I had of the $4 coffee. So it's really going to say X plus 3 right here. Right? Because these are the pounds. So now we got that. That's the hardest part. Now it's just algebra time. 4 times 3 is 12. Going to distribute 4.75 times X is 4.75X. 4.75 times 3 is, well, let's see, is 1425. I'm solving for X, so I think I'll subtract 4.75 on both sides. And I'll also subtract 12 on both sides. What does that give me? Does that give me 225? Let's see, minus 12. It's 225. I have to check with my decimal math. Okay, that went away. And what's 6 minus 475? 125. And then divide. Oops, $1.25. I got 1.8. 1.8. And remember, X was the pounds of the expensive coffee that we had to mix with the cheap coffee. I know you're thinking, well, I never would have thought of that. So we'll do another one though, and you'll see that you kind of set them up the same, and they kind of remind me of the ones we were doing in the last video, just a little different. Okay, let's do this. Number 12 is one of those acid ones. So again, I'm going to just have something times something plus, because we're dumping something in, and then we're going to dump something else in with it and mix them all together, and then we're going to end up with something. Okay, in this case, I have liters, and then I usually put my quantity on the right for some reason, and I'll put my values on the left. That's just how I do it. I'm going to put my percents, I think, on the left. So you can see that I'm setting it up the same way as I did the last problem, but the last one had money and pounds, money, pounds, money, pounds. This one has percent and liters, percent, liters, percent, liters. And usually this one back here usually just ends up being whatever's in that spot plus whatever's in that spot. Usually ends up going there. 60 liters. Okay, so there's 60. Now 70%, I'm going to write that as 0.7 because that's the decimal for 70%. And this one, the reason I'm doing this problem is I thought it was tricky because how many liters of water? So I'm going to use X for how many liters because we don't know. If it's water, what percent acid is it? It's 0% acid, right? If they're just adding water, because I'm putting percent acids right here and right here in all the places where it says percent. So that just gets a 0. There's another way you could have done it too. You could have said 30% water, you know, because 70 plus 30 is 100, and then you could have said 100% water, and I mean you could have. I actually did it the other way, and I got the same answer. But I want to show the way the the packet shows you. I need a 40% acid solution by the time I'm done. So I'm just going to add the 60 plus the X, because it's going to be 60 liters plus however much I dump in, which I don't know how much yet till I solve for X. Now this is nice because what's 0 times X? Well, it's nothing, right? 7 times 6 is 42, and that thing makes that thing move. I think 0.7 times 60 is 42. Should I check it? Just, I mean, better safe than sorry. Yep. Okay, and then 6 times 4 is 24. I'm feeling confident that I'm doing this right. We can check it though. If you don't believe me, 0.4 times 60. Right, that's 24. And then 0.4x. Okay, I'm solving for x, so minus 24 minus 24. Now I got 0.4x is equal to 18. No, yeah, 18. Divide by 0.4, divide by 0.4. And I got 45. So what is that, liters? There's 45 liters. I guess I should check that. Let's see if that's even what they got. Number 12. Yep. Okay, any more that I should do? I think I'm going to let you guys do the rest of them. Hopefully now that you saw how to do it, even if you can't figure out how to set the equation up, you can look in your packet and you can see how they set it up, and that'll give you some insight.